imagine a material that can act like a metal, a semiconductor, and a superconductor all at the same time. Imagine that inside this material, electricity doesn't just flow. It moves in a mathematically protected way, following quantum rules that defy classical physics. That's a topoconductor, a new state of matter where electrons don't behave randomly, but instead they follow hidden geometric pathways built into the structure of the material itself. And today, for the first time in history, topoconductors are being used in the real world. Microsoft has announced that the Majorana 1 chip, a breakthrough in quantum computing, relies on a topological superconductor to create qubits, solving one of the biggest problems in quantum computing. But before we get into that, let's break this down step by step. At its core, a topoconductor is a material that conducts electricity in a way that's governed by its topology, the mathematical shape of its atomic structure. In a normal conductor like copper, electrons move freely, but they scatter when they hit imperfections. This causes resistance and a loss of energy. In a semiconductor like silicon, electrons can be controlled, allowing for switching in transistors, but energy is required to manipulate them. In a superconductor, electrons pair up, and they flow without resistance, but only at extremely low temperatures. That's where a topoconductor is quite different. It has built-in electron pathways that cannot be disrupted, meaning electricity moves without scattering, even when defects or impurities are present. Its electronic properties are protected by quantum topology, meaning it behaves the same way, even if the material is deformed or stretched. It can transition between states. It can act like a metal, a semiconductor, or a superconductor based on external conditions. Think about a coffee cup and a donut. At first glance, they seem like completely different objects. But in topology, the branch of mathematics that studies shapes can be stretched or deformed without breaking. A coffee cup and a donut are essentially the same because they both have one hole. Crazy, right? Now apply that idea to electrons inside a material. In a normal material, electrons move like cars on a busy road. They collide with obstacles, they slow down, they lose energy. But in topoconductor, electrons are forced to follow specific quantum paths, as if they were on a high-speed train track with no roadblocks. This is because in a topological material, certain electronic states are protected by geometry, even if the material is impure. The way electrons behave remains unchanged. So this means the topoconductors allow electricity to move with minimal resistance, but without the need for the ultra-cold temperatures required by superconductors. And that is what makes this game-changing. So, look, now that we know what a topoconductor is, let's talk about why Microsoft just built an entire quantum chip around one of them. One of the biggest problems in quantum computing is qubit stability. Traditional quantum computers, they use super-cooled superconductors, but the qubits are extremely fragile, and they require thousands of backup qubits for every one that works. And Microsoft solved this by using topological superconductor. So instead of conventional qubits, they created Majorana qubits, self-stabilizing qubits that correct their own errors. These qubits, they're way more stable, reliable, and scalable than anything in human history. Well, known human history, that is. So this means quantum computing may finally be practical, with Microsoft claiming that the Majorana 1, this chip, it could lead to a 1 million qubit machine in the very near future. And if that happens, we could see quantum breakthroughs in drug discoveries, new materials, AI and machine learning, and so much more. Creating AIs that process data more like human brains, superconductors, better batteries, higher efficient solar panels. It's all at the tip of our fingers, right? So it's not just a breakthrough for science. It's literally a race for control of the future. Quantum computers powered by topoconductors, they will eventually crack today's encryption systems. And that means whoever develops the first large-scale quantum computer could decode and go crazy with any encrypted information on the planet. This is why governments and corporations are pouring billions of dollars into this technology, because the stakes are so high and they're global. And whoever dominates quantum computing will ultimately dominate cybersecurity, AI, and the entire industries. And it all starts with a material that didn't even exist outside of theory until recently. For decades, topoconductors, they were a curiosity in theoretical physics. But now they're powering the most advanced quantum processor ever built. And this isn't the future. This is right now. These are Interesting Things with JC.